So give it up for Josh.
Welcome everyone to day 2. Hope everyone had fun yesterday and had some fun last night as well. I see a few tired eyes. But yeah, I just want to say thanks to all of you for making this happen. I love regional conferences, and the smaller it is, the more intimate it is, and so it's definitely makes it worth traveling halfway around the world. Maybe all the way around. So I'm going to talk about smarter applications with Ash, LLMs, and MCP. It's a bit of a mouthful. But first, who am I? I live in Sydney in Australia. I'm usually the person that's traveled the most, getting a reputation. But I started Elixir in 2015. That was 10 years ago now, which is, makes me feel old. And I loved it so much that I founded Alembic in 2017, so we build Elixir applications for people. We did other stuff too, but now we're mostly doing Elixir, which is awesome. And then I met Zach and I discovered Ash in 2022. And so we've been working on that pretty hard for the last 3 years. Zach's been doing it for a bit longer, but it's come a long way. So I'll take you through, what we've been doing there. I've got 2 dogs. I'm missing them. I see them sort of at the end of next week. But yeah, I love hiking in the outdoors and trying to get back to long distance running. We'll see how that goes. So what I want to talk about is a familiar problem, potentially, if you've been building apps for a while, particularly web apps, particularly for various customers. You'll recognize that modern web app development is complicated. What you want to build is the valuable things above the waterline, but what comes along for the ride is all of the stuff below the waterline, and there's a lot of it. And so, this is the stuff you have to build to get the stuff on top of the waterline, which is the valuable bits. And, the iceberg that you see above the water is where all the innovation is. It's where your customer's differentiation lies in your products. It's where all the core IP is. It's where the value really is. And the rest of the stuff is arguably solved problems. Our clients don't think that they have to pay for logins one more time. They tend to not value that. They just expect it. And the conversations tend to go, hey, you guys have solved this before, right? It's like, yeah, kind of. And it's table stakes, and customers tend not to value it. They want to focus on their business problems, the core things. And I would argue that any time we spend down below the waterline is kind of wasteful. So, this is my sort of the start of a wish list for what really should appear when you start a new web application on day 0 before you've even started solving the problem. These are all the things that I think should be there. And we're working on that list. And, Ash can provide some of those things, as we'll see in a bit, but, there's a lot more to go. We want to solve the top of the waterline problems, and this should just arguably be them. So Ash sets out to solve some of these problems. We'll dive into the tagline, which is spend the time modeling your domain, derive as much as you can from that. And yeah, we want to build powerful Elixir applications. So what is Ash? We've spent a bit of time at conferences talking to people about what Ash is. Like I said, 2022 was the first ElixirConf US that Zach and I went to. And we've refined our messaging. So this is hopefully, a crisp version of all of the things we've tried to tell people about. But there's a lot there, and it's complicated. So this is, an attempt to break it down. So what is it? It's a declarative approach to building applications. And it's an application framework rather than a web framework. And we'll see why that matters in a little bit. It's resource-based. We're modeling our nouns in a sort of typical relational style, which is familiar. But we're agnostic of UI layer. Now, if you sort of remember the 3-tier architecture, which I have a diagram for in a second, we don't want to be tied to our UI layer. In JavaScript land, that tends to change pretty regularly. That's sort of a classic joke. I won't make it now. But yeah, UI layers can change more rapidly than your core application, which is where all your business logic is and your asset for your application is. You want to keep that, even if the UI changes. And we're also agnostic of data layer, so we can swap those around. It shouldn't really matter, and your application shouldn't be tied to where you store your data. And I think this is the main point. Ash is really focused on modeling your domain and modeling your business logic and keeping it in one place, which is a pretty valuable thing to have. We're taking the DSL concept that sort of started with Rails and Active Record, which was a great idea, everyone loved that. But Ash takes that way further and uses DSLs to model everything, and that's the declarative part. We're taking domain-specific languages, little languages that let you model your domain and configure your application. And the powerful part about that is it represents your system as an introspectable data structure. And we'll see some of the powers of what introspection can give you, but that's the power behind deriving the rest. And so, yeah, we do all of that, and out of all of the modeling and writing DSLs, out pops a robust Elixir application, typically with a front end, but it doesn't have to have one. So another way to think about it, and this is if you take away one thing about what Ash is, we're writing DSLs, those get turned into data structures, and the data structures are pretty simple. There's a lot of them, but they are simple. Often people suggest that there's a lot of dark magic, and you can disavow them of that notion by saying, no, it's just data structures. Then we look at those data structures through introspection, and we can generate pretty powerful tools. So that's the big idea. DSLs, simple data structures, powerful components out the back. So this is the three-tier architecture. Does everyone put your hands up if you sort of are familiar with this three-tier architecture? UI, business logic layer, data layer. It stood the test of time. It's pretty powerful. We want to keep those layers as separate as possible. So where we start with Ash is we want to model and work at the application layer in the middle where all of the guts is. Remember Phoenix had this whole, there was a period where they were focusing on, we are not your application, we're just a web framework. Now they have to have opinions just to be able to do end-to-end demos. You need to have some opinions in that middle layer, but they really didn't want to have any strong opinions. By the by, Ash comes along and it gives you strong opinions so that you can model a good application so that you can put great UIs on top of that. But if the UI changes, you've still got a great, powerful, robust application underneath. Now, the blue things on the top, we've got some tools to generate and help you do things in the UI layer, but really all of those are optional. What isn't optional is storing things in a database. I mean, you're typically going to want to do that unless you hate data. We want to generally default to Postgres because it's pretty great, but there are other options. And look, if you have an app that doesn't store data, you don't have to persist it. But this is a mental model for we're working in the middle and we're generating all things on the top and the bottom. All right, let's move on. This is what an Ash resource looks like. I'm not expecting you to sort of read the code. I just want you to get a flavor of, this is a very simple user. We've got DSL sections. You can look at the attributes. Those are the fields. We've got the relationships. The user is the noun. And we've got some Postgres configuration for storing user data. So that's a simple resource. That's the DSL. And this is what the DSL produces. It's one sort of introspected slice of it. We've asked at the top for the attributes of the user resource, and we get a list of those attributes. And that's a pretty simple set of structures. There's lots of data in there, but conceptually, that's pretty simple. And so this is what we're introspecting. But we don't stop at nouns and relationships between nouns. Ash also models the verbs. Now, this is pretty important because we'll need this later. But what we're doing is modeling the actions that resources can do, and it's not just CRUD. We can model all kinds of actions, and we want to typically model those using domain language, so that your customers and users and developers can understand what those things do. But yeah, we're modeling verbs. This is powerful stuff. We're kind of programming them using the DSL. And the reason behind that, and this looks like, well, why wouldn't you write a register function? It's much easier to introspect data structures than code. So introspecting a function, an arbitrary function, is very difficult. What we want is a standardized structure that we can get all the information we want out. And we're going to need this later. So we can have simple actions, we can have really complex actions. If you need super complex actions, hello, there we go. All right, so yeah, if you need super complex actions, there's a Ash extension called Ash Reactor, which does sagas and orchestrated workflows for much more powerful step-based and revertible workflows. So we can expose these actions externally. So typically, if you have a mobile app, I mean, obviously, if you're using web, you're using live view, right? But if you have a mobile app, for example, GraphQL is a pretty handy way to expose what your application does to the outside world and to other clients. It's best not to use it for external interfaces that clients that you don't control are using. So therefore, what we can do in that case is have a REST API using JSON API and the Open API standard. And the nice thing about this is you can have both at the same time, generated for you from your domain model that you've modeled. And remember those context functions in Phoenix that you put in a module and you call ecto? Code interfaces is a way for Ash to write that data fetching code for you. So that's pretty handy. So you're basically doing a lot of declaring and leveraging the introspection capabilities to generate most of the stuff you would otherwise do, which creates standardization, which is pretty great. So remember the tagline, we're modeling our domain, we're deriving the rest. There's lots of things we can get here. But what about generating tools for LLMs? So that's the rest of this talk. So Ash knows almost everything about your application, and we're planning to make it know more. And Ash kind of is your application in the sense that Phoenix isn't. So what cool stuff can we do with these introspection superpowers? So let's have a look at an Ash application example. There is an Ash book, and I'll show you the cover in a second, at the end actually. But this is the sample application that you build as you follow through the book. It's called Tunes. It models a simple domain of artists and albums and tracks and so forth. And so we're going to use that as our sample. And I'm not expecting you to read all of this code, but this is the main concept. Domains are, you can think of them like Phoenix context or bounded contexts. They're groupings of your resources or your nouns in your system. So this is the music domain, and we've got artists. We're defining those functions. That's writing that sort of Ash or ecto data fetching code for you. And we've got standard looking functions that represent the interface to our application. So these are the things that we would expose out to either the UI or APIs and so forth. We've got things for artists, we've got functions for albums as well. And this is a bit of a wall of code, but I just want you to get the flavor of what a more complex Ash resource looks like. We've got some set up here for the GraphQL REST APIs, some Postgres config, but I want you to focus on, here are the actions that we're defining, and it's done all through sort of the DSL. These are the attributes, so all of your fields that you represent that artist resource with, and importantly, baked into Ash is policies that describe who can see what in your application, who can do what. So we don't need to understand those, but security is important. It's often an afterthought, but in Ash, you really can bake that stuff in. And that's going to be important when we expose that to the outside world. We don't want people doing things that admins could do. So that's the app that we're going to do a few things with, but let me switch over to the LLM side. What I want to do is sort of give you my version of an abridged timeline of how I thought about major LLMs. They didn't really seem good at this point. I tried them out. They were kind of slow. They didn't really do what you want. I tried to do a bunch of things with it, and it didn't seem super useful. And they couldn't use tools. They were really just completing the next word and generating, more tokens from your input. But GPT-4o was probably the time, and this was basically a year ago. This came out, and it was like, ooh, this is getting pretty interesting. Not only are they much faster, they're multimodal. They can use tools via what OpenAI called function calling. And they were starting to be agentic. So this was sort of the first point I went, oh, there's something here, and this is going to be pretty interesting. And they started being really useful. But I fell in love when I discovered 3.5 Sonnet. That was really pretty amazing. First of all, it was a lot faster. It started to do a lot more reasoning. It was doing it in it was the start of the reasoning models, and it was basically calling tools and generating artifacts. And I thought that was pretty amazing. And it was starting to show promise that it could actually write code. It wasn't always good, but it was sort of the start of the agentic models. And then everything kicked off. So now we've got, much faster models. They're much more capable. They're doing deep reasoning, and I probably should have put that in quotes, because it's really simulating reasoning by just generating more tokens. But based on what Kevin said with the vector addition, which was sort of mind-blowing to me, because I hadn't thought about vector addition in that as sort of finding the semantics. So really, you're generating more tokens to find the bits in the sort of the semantic index of an LLM's network to get the concepts and the output that you want. And so, I don't know what fully agentic means, but we're sort of entering into an age where we've got really quite excellent reasoners or simulated reasoners and tool users. And so that's going to be pretty powerful. So what are tools? They're really just selecting and running functions with structured inputs, structured outputs. Reasoning, like I said, is just literally generating more tokens to simulate thinking. You could argue that it's not really thinking, but it looks like it. It does. And agentic is, in my definition, more reasoning, more tools, gives you better output for some definition of better output. We're not there yet, but I think we can find applications where they're definitely good and reliable almost all the time. So, who saw the Tidewave release? Awesome. So this is pretty exciting because it's great to know that other people are thinking about this. But let me give you a quick rundown on what Tidewave does. It is runtime intelligence, so it's introspecting your working Elixir application. It also does Rails, which I think is pretty awesome. But it's doing those four things. It's looking at your database, it's looking at logs, so you can sort of at build time be understanding your system as it's running, evaluating code, looking at documentation. There's a whole bunch of tools in there that are pretty useful. Now, we're going to see why they're able to work with all of those tools. But let's talk about tool usage. At the start, OpenAI sort of standardized function calling and tool usage. So what you're doing is sort of giving a structured, and this is probably a better example, you're describing functions that an LLM can use and select from and then call using a sort of structured description. And you need to describe it well to the LLM so it knows to pick the tool, and then it knows how to run it, and then you describe the output so it knows how to interpret what the output was. So that's basically what a tool call looks like, and it's structured. And then last year at ElixirConf US, Zach started this little experiment called Ash AI, and showed off a demo at the end of his talk, which, has that been released yet? the ElixirConf US videos are still coming out, so look out for that talk, because he does a pretty cool demo. But this was the first draft, and it was an early experiment to prove the concept. Used OpenAI function calling to start. And basically what we were doing was exposing all of the actions in an Ash app, kind of like we would do for GraphQL or REST APIs, and preserving the security of Ash authorization policies. A couple of issues with that, and I won't talk about too much about that, but yeah, there were limitations, and it was fixed and coupled to OpenAI APIs. And this is what it looked like. You sort of have to provide a prompt. Here we get a user that we can then go and start like an interactive chat in the console, and yeah, basically can list out and introspect all of the things you can do with the app, given the user's capabilities. So we're respecting security there, and that was sort of the first checkpoint of, hey, we can use the introspection capabilities of Ash to reveal this to other tools that LLMs can use, which is a pretty cool idea. You know, we can throw in natural language queries, and we saw some of this yesterday, and we can see the queries that are being run through the tool call, and then we get the output. Now, the LLMs are interpreting that structured output and formatting it in whatever way. You could probably guide it with better prompts, but you know, this is what it comes up with by default. And then this is a sort of demonstration of, if I'm not an admin and I don't have access to create artists, then I get the Ash authorization policies applying and not letting me do that. So, I mean, the key point here is that when we expose capabilities, we want to expose, well, make sure that the security policies are in place, and Ash does that. And we leverage those, you know, through introspection and generation. When we're an admin, we can totally create a punk artist, and Claude here is going and, you know, creating a new artist. It didn't even really get any information about what to do, so it just made up fake data, which is thank you, Claude. And so it noticed that, yeah, the artist didn't have any albums, so not only created the artist, but it created albums as well. So, yeah, kind of cool. But the issue with, you know, the first version of that was that it wasn't sort of standardized, and along came the Model Context Protocol, or MCP, which I think everyone knows what that is by now, or at least has some idea. They call it the USB-C of LLM connectivity. And you can think of it like an API for, you know, giving LLMs tools. And so that was only released sort of early December last year, so a lot has happened, but it's become the standardized open protocol for, you know, LLM clients, tool servers, and all of the communication between that. Now, it's not perfect. There's limitations here. It's basically just JSON RPC. You can either do that over standard I/O, which is typical, which is why you might need a proxy, and you can use SSE, and there's other things coming. But we can connect all of our LLMs to that, and all of our editor, you know, agentic editor tools like Cursor, Windsurf, etc. It's easy to switch models, vendors, and attach new servers, so you've got like a plug and play. So the USB-C, you know, metaphor isn't terrible. And OpenAI just got on board with this, so now we've got, you know, pretty much a de facto standard. And there's been a massive explosion of resources and implementations, and it's definitely worth checking out and following. So this is the architecture. We've got a host, which is either your LLM, you know, Claude Desktop, or your IDE like Cursor, or any other tool that you know wants to call a tool. And so we can have servers that, you know, can basically represent any kind of function you like. It could be listing files in a directory, it could be fetching data, it could be calling remote services. So really the sky's the limit there. And what does this look like in Claude Desktop, for example? So how do we add tools? So you basically make a little configuration, and the tools show up, you know, in a little thing here, and different hosts will have different mechanisms, but you can apply tools and you can see what those are. So here we're describing the tunes Ash MCP server, and we've got all of the things that we've exposed out to Claude. There's different configuration options, and you can have lots of different tool servers to give you sets of tools. I think the important thing to realize here is that good descriptions, so good names for your tools, to make it tool selection basically unambiguous is really important. So good descriptions there, super critical. This is how you typically go, configure an MCP server for usage in a tool. This is Claude Desktop. And this was my example where I just built a pretty simple standard I/O MCP server, and this is us calling that. So what does that look like? Now we can get Claude Desktop to do the same thing that we were doing in the IEX example before. So, same stuff. Give me artists from Australia, and it'll go and look for that. The nice thing about Claude is that it shows you what the queries were and what the results were. So you get a bit of debugging. I'm not going to go into debugging, but there is tools for this. What are their latest albums, full biographies, etc. And so this is probably the key part of this. This is how we do Ash introspection. So what we're doing here is revealing the tools in a list for the MCP server for Claude to come along and read what the capabilities are. And all we're doing is going through, finding our domain, going and getting all of the resources in a domain, then getting all of the actions in that resource, so that's sort of the hierarchy. And then we're just listing out what is the tool name, and this is the tool definition that MCP servers need that gets turned into JSON over on the tool call and the tool listing. But it's pretty simple. There's not a lot going on there, and this is how simple introspection basically is. So it wasn't a lot of code to basically look at what Ash is doing, introspect the data structures, and then reveal that out as an MCP server. Now there's more to it than that, but that's the core. This was my first attempt at creating a DSL section to describe which tools will be exposed. This is not what the current version is, but it's pretty close. So you can see that how we do GraphQL sort of expose actions there is going to be pretty similar to, we map basically an action and a name of an action to something that we've described in our Ash resources. So I won't spend too much time on this. There's a few challenges. Standard I/O and SSE probably aren't necessarily the best choices. There's a lot of version changes. And the new version does change the spec significantly, and it's not totally backward compatible. So, it's moving fast and it's breaking things. But we need to be pretty clear about how and why we, expose and what we expose out to the outside world. We don't really want to expose non-critical functionality to LLMs unless we're pretty sure about what the outcome of that is going to be. There's a few things we've run into. If you provide an LLM far too many tools, it starts struggling to select which one to use. And especially if there's ambiguity or there's lots of ways to achieve a similar thing, you may get different tools called different times you ask for the same thing. So limiting the number of tools is going to be important when you're working with these things. So we need to make them easy to find and easy to select and call correctly. I'm running out of time, so I probably won't go into the security challenges, but there's, when you're talking to remote MCP servers, be really careful because there's no way of telling what that thing does. And if you're attaching it to local shell calls, which people do because it's helpful at build time, then you could have some trouble. So don't let the LLMs run shell commands. So what's next? We've sort of shown what's possible here, but there's lots more in store. you can go and have a look at Ash AI today. There's a link at the end. Check it out. Zach's going to release it next week officially at ElixirConf EU. And there's a bunch of stuff in there. There's vector embeddings for doing sort of semantic search over your fields in your resources. There's going to be Tidewave does dev tooling rather than exposing your functionality out to the outside world. So yeah, we're going to have an MCP server for dev time tooling for, as you're building, what can LLMs tell you and help you with when you're building. But we also want to be able to expose application capabilities to the outside world, to other tools. So there's sort of two different lenses there, and we're sort of covering both of them. There's some API key stuff for authoring MCPs, so that's pretty new, and there's some more surprises in there. So take a look. Yeah, this is not a solved problem, so it's really a chance to get in there and experiment with the new tools, see what the tools can give you, how it changes your workflows, and the MCP spec is evolving pretty rapidly, so we'll keep an eye on it and see what it enables. I do need to give Zach and Rebecca a shout out for writing the book, which is nearly at the end of its beta. And when are we expecting a published version? Shrug. No idea. No promises. But the content is done, and publishing a book, we don't know how long that takes. So expect one soon. But you can buy the beta now. And it is, by all accounts, and I'm not being biased here, a really great read. Lots of people have told me so, and yeah, it takes you through building an application with Ash. And coming soon, Ash AI. Thank you, everyone.